Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on antenna. On my previous video discussion on antenna, I actually focused on dipole antenna. This video, I will focus on monopole antenna. To be more precise, quarter wave monopole antenna. I'm going to focus on the design aspect, the working principle of monopole antenna, and also where is actually the real application of monopole antenna. Next, I will discuss the key difference between dipole and monopole antenna. All this will be the objective of this video. Guys, this is my email. If you have any question regards on this discussion, please drop me an email. Okay, or if not, I actually prefer you guys to ask me your question through the comment. Before I continue, I'd like to urge you guys to help me by like this video. Guys, it's free and it's just a few seconds. Help me press the like button now. For those who are new to this channel, and if you want to encourage me, please consider to subscribe to this channel and turn on your notification bell. Once again, thank you so much for strong support. A quarter wave monopole antenna, in fact, is one of the simplest and also the most widely used antenna in real-world wireless communication system. The diagram on your right actually show you a picture of quarter wave monopole antenna. So I guess this antenna you should be very familiar. It is widely used, for example, Wi-Fi router, walkie-talkie, and also many forms of radio communication. Let's take a key look on the difference between dipole and monopole antenna. For dipole, in fact, I have described this based on my previous few series discussion on antenna design. So in short, for dipole, okay, the di means two radiation element, one over here, another one over here. So therefore, with two radiation element, so it is known as dipole. So in short, dipole antenna has a length roughly about half of wavelength. As for monopole, it is actually quite similar with dipole. So from here you can see that it also have a quarter wave of radiating element, but for monopole, it only has one radiating element. On the other side, in fact, it is actually grounded. Okay, so basically you can again relate this. So basically for this antenna, typically they will join to a PCB. So PCB often has this ground surface. So basically you can relate how these two things actually look like. So I will explain a little bit more on the key difference between dipole and monopole antenna. Let me explain the key difference between dipole and monopole antenna. Firstly, okay, for dipole, it is actually a balanced system, okay, which means that they can be configured in a differential mode. As for monopole, in fact, it's a unbalanced system. So therefore, this part can be easily connected via coaxial cable. So next, let me focus on the dipole antenna first. A dipole antenna, okay, so in EM, actually require two radiation element, which I have highlight on my previous slide. This is one, this is the two radiation element. So one arm actually carry current in one direction. So basically, when one arm actually carry the direction, let's say it move up, so this portion they also move up. After that, okay, basically you can see that the other arm actually carry the current in the opposite direction. Okay, basically this is also moving up, so they actually move towards the supply, but for this part they actually move away from the supply. So basically this is what it means. One arm actually carry the current in one direction, while the other arm actually carry the current in the opposite direction. So the total length of dipole antenna typically is about half of wavelength. Now let me focus on quarter wave antenna or monopole antenna. So over here you can see that they only have one physical radiating element, as you can see from here. On the other side, in fact, it actually has a ground plane. Okay, so basically this ground plane can be a real or a virtual ground. So basically they are actually act as a missing part for the other radiating element. So in electrically, okay, it actually behave almost similar as a half of a dipole antenna. Next, let me explain the radiation pattern, the key difference between dipole and monopole antenna. So again, let me focus on the dipole antenna. Okay, so this is what I have described in great detail based on my previous discussion on dipole antenna. So basically, this is how the dipole antenna will be at. So basically, you can see that they basically radiate out of this so-called radiation element. So if you look at the top, okay, they can be like a donut shape. Okay, they don't radiate at the end of the tips of this dipole antenna. So basically, this is for the dipole antenna. As for monopole antenna, it is actually half of dipole antenna. As you can see from here, they actually cut into half. Okay, because okay, over here is actually the ground plane. Okay, so the radiation above the ground plane, in fact, they are very similar to dipole antenna. However, okay, below the ground plane, in fact, there is no radiation. So basically from here, you can see the key difference between dipole antenna and monopole antenna. This is focusing on radiation pattern. Before I go in deep detail, how does this monopole antenna actually work? I need your help, guys. I need your help by like this video. If you have learned something from this video, I strongly appreciate if you can help me by like this video. Again, if you have learned something, help me by subscribing to this channel and turn on your notification bell. Once again, thank you so much for strong support. I have 7 steps to describe how a quarter wave monopole antenna actually works. Step number 1, AC signal is applied. Okay, so basically this is the source of AC signal. It probably can come from the transmitter, and this part can be fed through the coaxial cable. Next, the voltage actually alter, okay, between positive, negative, positive, negative. Basically from here you can imagine that when this is actually positive, okay, after that it will change to negative. With this, they actually create an oscillating electric field at the base. So they create a E field at the base of the monopole antenna. Next, step number 2, current start to flow up, in fact up and down the rod. Okay, so when voltage is positive, so over here, imagine when it is actually positive, electron actually will move upwards along the antenna. So when the voltage actually change to negative, electron will move downward. Okay, so basically with this, you can imagine that the current is constantly oscillating by changing the voltage plus and minus. You can imagine that the current move upward or downward along the rod. So this is actually step number 2. Current start to flow up and down the rod. Step number 3, standing wave actually form. Okay, so when the length of this radiating element is around quarter wavelength, okay, standing wave actually form. Okay, because the antenna length need to be around quarter wavelength. With this, okay, the current will be maximum at the base. Current will be maximum at the base, and current will be near zero at the tip. On the other side, the voltage will be minimum at the base, while it will be maximum at the tip. With this, they actually create a standing wave pattern, which I also described on my dipole antenna. Next, step number 4, the ground plane actually create a mirror antenna. Okay, so basically imagine there will be a radiation element. Okay, so this is actually what it means by a mirror antenna. The ground plane, in fact, reflect the electromagnetic field. So basically from here, okay, the E field actually reflected by the ground plane. So therefore, it actually behave like an image of the missing half. Okay, so now the system, in fact, act like a half-wave dipole. So this is step number 4. Okay, basically with ground plane, they actually mirror the antenna. Coming to my 5th and 6th step. Okay, so step number 5, field actually expand into space, okay, which means that this antenna actually release the electromagnetic wave into the air. With oscillating current, in fact, they produce both the E field and also the H field. Okay, so after that, this field, okay, which is the E field and H field, they actually detach from the antenna. They basically travel outward as electromagnetic wave. Imagine this, basically they release the wave, okay, in a circular basis. It become bigger and bigger. So basically this is how they actually release them into the air. Next, step number 6, the radiation pattern actually form. Okay, so the energy spread outward in a horizontal donut shape, which I have drawn just now. So they basically so-called move it in an outward basis in a horizontal donut shape. Very little will be radiate straight up, okay, which means that at the tips here over here, okay, very little will be spread out at this so-called the tips. That's why it is great for radio communication and mobile antenna, okay, because we can predict that this is actually the radiation pattern. So it will be good if I put the receiver, okay, which is 360 around this monopole antenna. Last step, step number 7, continuous oscillation, which means that continuous radiation. Okay, so as long as the AC signal keep oscillating, the current will also oscillate. And with the oscillating current, both create the oscillating E field and H field. And thereafter, the E field and H field will be continuous emit out of this antenna. So this is how the monopole antenna actually work. Basically, from here is a short summarize how this quarter wave monopole antenna works. With this, I'd like to end my discussion. Please help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.